think we can start. Thank you everyone for joining for another seminar of our RIOT Club. And thank you so much to our presenter, Dr. Jon McPhetres, who will today talk about how to use R Markdown. Dr. Jon McPhetres is a member of Durham University, is our staff member. And before joining Durham, he was at University of Rochester, where he finished his PhD, and did his postdoctoral studies at University of Virginia and at MIT. And he has two very interesting, exciting areas of research. One on public understanding and attitudes towards science and rejection of science, and then another one combining biological insights with psychological insights, trying to understand the underpinnings of goosebumps. So today we will talk a little bit more specific about his, methodological skills, but hopefully also we'll learn a little bit more also as well about research. So the presentation will last about 30 to 40 minutes. You can pose your questions in the meantime in the Q&A. However, maybe you can also wait towards the end of the presentation because things will be clarified towards the end. And then we will leave enough time for everyone's questions. Yeah.
Cool, thanks, Maya. Markdowns, I love Markdowns. It took me a little bit of time to get started using R and then to get started using Markdowns. And it took me even longer to really realize the potential of Markdowns. So I hope that today's workshop will give you some practical skills that you can use in your own research. And by the end of today, I hope that you can do some basic things in Markdown to report the results of your own experiments. And I'll share a file at the end. And then this video will also be posted in case you want to review it and go over some code that I share as well. So all that'll be made available. And I hope everybody can see me and hear me okay. We're loud enough and all that. So to get started, the question is, what is a Markdown? And a Markdown is a formatting language used to create and print documents from the RStudio window. So this makes reporting the results of your research easier because you don't have to transcribe results. But the main benefit here is that not having to transcribe your results by hand or copy and paste will reduce errors and will probably also save you time as well. So today's tutorial, I'll walk you through how to use our Markdown, but I'm going to assume that you already have some basic experience in R. So nothing too extensive, but just basic things like you understand how the RStudio window works. You can generally import some data files or understand how some basic commands work. But what I will teach you how to do, I'll assume that you've never used a Markdown file instead of the basic R scripts, and I hope that you'll find them easier than using the basic R scripts as well. Excuse me. So by the end of today's talk, you'll be able to do some basic things in Markdown. You'll be comfortable enough to seek out some more advanced resources and improve your skills even further. But today is just going to be a real light introduction. We're going to learn how to compute some results, how to report them in a table, and how to report them in text. And then at the end, I'll share some other options and packages for some more complicated tasks. I also want to note that I'm going to be teaching you a sort of Markdown light. This is how I use Markdown. There are a lot of ways to use Markdowns. Once you get the basics down, hopefully after today and after a little bit of practice, you can print your Markdowns to PDFs or HTML documents, and you can share them on your GitHub page or your website or whatever it is that you want to do. There are a lot of ways to use Markdowns, but today we're going to be talking specifically about using Markdown to print documents to Microsoft Word. And I'm going to share my screen and show you a little preview of what we're going to get. So we start off with a Markdown document like this, and we're going to end up with, a Markdown document like this that's going to have some text, maybe some headers, maybe some tables. We're going to have some results in the text, some more complicated sorts of results or a correlation table. You can even print some graphs into your Word document as well. So that's the goal of what we are going to end up with. And it starts from a basic R Markdown file, just like this, like you may have seen before. Now, the reason that I use Word is because just basically it's what everybody does, right? All of my collaborators use Word. Generally, I need to submit a Word document when I submit a paper to a journal. It's also really just easy to use Word to write papers, and I'm pretty comfortable writing in Word. So we're just using Word. But it's important to note that using Word limits some of our options for formatting. And you'll see that our final document is not perfect. But the main thing here is that we can get like 90% of the way there, right? We don't have to transcribe our results. We don't have to copy and paste. And that's really the main benefit here, because everything about your results are contained and easily reproducible by simply opening up this R Markdown file. So with a little bit of formatting in Word, we have a publication ready document. But again, after today, you should feel a little more comfortable using this, and you should have what you need to get started and get over that initial hump of using markdowns for planning and reporting. So that's what markdowns are, and that's what the goals are. And to start, we're going to open up RStudio, and we're going to make a new markdown document. And we can give it a title, intro to markdown. You don't really have to give it a title, but you can set some defaults right here. And the first thing that we're going to notice is there's some information here that we don't really need. But the first step is I'm going to have a folder on my desktop. And in that folder is going to be my data file. I've just called it data.csv. And it's just some basic data that I generated randomly. It's got some variables and some dichotomous variables and some demographic type things. So what I'm going to do is I'm just going to save this markdown file to the desktop. To the same folder where my data is. Okay. So I have another file in here, but basically I've got my data file and my markdown file in the same folder. Now, the reason that we do this is because this sets the working directory for your markdown file so that you don't need to find paths or file names or anything like that. Basically, we can just tell it the file name, or if you want to save multiple files in that folder, it's really easy to access all this stuff. So the markdown document here, you may need to install R Markdown by doing an install.packages, and I believe it's just called R Markdown. And if you do need to do that, I actually don't remember. It's been so long since I've installed this, but I think that this should install everything that you would need to do to print everything to Word. If you want to print to PDF, though, we're going to need to do some extra steps, and we're not going to cover that today. So just know that that option is there if you don't have the markdown option. So once we open a markdown document, it's going to give you a little bit of information, right? It's going to give you the title that you put, the date, we'll say the output that we want, and it's going to give you this chunk, which are options. Knitter is what we use to actually knit the Word document at the end after we've typed some things. And then it's going to give you some information about how markdowns work, including a plot, different stuff like that. For now, we're just going to delete everything except the first chunk. And we're just going to start from scratch, and I'll show you how to load this data and do some basic analyses. So I'm just going to load my data, and I'm going to call it read CSV. My data is just called data.csv, and that's just going to load this data frame. Whoops. And these are the variables that are in my data frame. So notice this is why we set the working directory. Otherwise, I don't have to do users / Jon McPhetres and all that. We can just load data.csv right from our working directory. So the first step that we want to do is fix my monitor. We want to conduct a linear regression. So I'm going to use the LM function, and I just have some variables that I made up here. So say we want to compare happiness by condition from DF. Now, if we run this, this is going to be our linear model, and we can print the results in a regression output or something like this. This is the basic output that it gives us. If we want a summary table, we can ask for summary of LM, and it's going to give us this kind of text. Now, what you might want to do is you might want to sort of copy and paste this, or look at your R output window and then type these values into your Word document. But the goal here is to avoid that. So we get R to make us a nice table all on its own. And to do this, we need a few things. We need a couple packages. So I use, for example, the I use some functions from Magritter. I'm going to use a package called FlexTable. And a few other things as we come to them. I'll load some different packages. But just know that you may need to install some of these packages as we go. So to begin, we're going to get this summary table. And what we want is we specifically want these values. Okay, we want the B coefficients, we want the T values, maybe we want the P values, and we want them in a table. And we need to know how to get them. And there are two ways to find this information. So if we look at the output in our help document and we find the values, it's going to tell you all of the values that the LM models are going to print. Coefficients, it's a named vector of coefficients, residuals, okay, call, terms, contrast. You've got all of these stuff. And what we can do is we can tell R to save just part of them if we want. So coefficients seems like a good way to start. And if we want to just save those coefficients, just like we would use this $ operator to specify an object or a variable or a column inside a data frame, we're going to tell it just to print the summary of the coefficients. So that's a little better. But what we really want is we want this to be in a data frame. So I'm going to use the pipe from the Magritter package, pipe it into data frame, and it's going to save this into a data frame. And that's going to save, we're going to have a really long p-value, which we'll fix in a minute. But that's going to have the condition variable. Okay, maybe we want an interaction, right? Oops. It's going to spit out just a table with whatever our terms are, okay? Condition, rating, and then the interaction. And it's going to give us all the coefficients for this. So the idea here is that we could just hit knit to Word, and it's going to spit out a document for us that looks kind of like this. Okay, I know that this is, oops, went away, kind of small. We can open up our Word document. And it's going to give us an output that looks like this. So this is step one. We've got our estimates and our T values and things like that, but it's not in a pretty sort of workable, usable format. So we need to do a couple other things. And this is where the FlexTable package comes in, because we can just pipe this into the FlexTable function. And now everything's going to be in a FlexTable. So I really encourage you to install and use the FlexTable package. It's really easy to do some more in-depth modifications on these kinds of tables and things. But we can actually do a couple other steps to make this much nicer. We can already see that just by changing our coefficients into a data frame and saving it into a FlexTable, that we get an APA-style table with the book tab top and bottom lines like a regular table, but we're missing a couple things. We don't have names for rows. We can make these tables a little bit nicer. But this is the crux of everything that we're doing is we need to select the results that we want, save it into a data frame, and simply pipe it into the FlexTable function. And then when we knit to Word, it'll print out our results in the way that we want. So I'm going to do a couple different things here. First, I'm going to round my results to the third decimal place, and that's going to give me some 3 decimal points. That's going to fix my really long p-values that were really annoying. And I'm going to do that before FlexTable. Okay. Now, after rounding and before piping in a FlexTable, I'm going to use another function from the Tibble package. And this is going to save my row names to a column. It should pop up. And then I'm going to pipe it into FlexTable. And what that's going to do is, if we notice, our summary table has these names. It's the name of the row, but it's not actually a column. It's a different piece of information. And that's going to save them to a column. Our result is going to look like this. It's going to name it intercept, condition, rating, interaction, etc. So it'll actually save those. Now notice that it called it row name and it kind of squished it a little bit. We can actually give these a column name, right? We can call it term if we want to, term. So the result of this, when we select knit to Word, it's going to go through some stuff down here in the console, and then it's going to print this document for us. It's going to look like this. we have our table, and it's going to take, as I mentioned, a little bit of formatting. We can stretch some things out if we want to. We could use the layout option and auto fit to contents. And then we get basically a pretty nice table. There are other ways to change the names of the variables and the names of the columns here, but basically you could go through and you could change this to sort of p-value if you wanted. Minimal formatting, but the point is we no longer have to copy and paste the results by hand. So the other thing that we need to notice is that, yes, we have the table here, but we have some extra stuff that we don't necessarily want. We kind of want a clean document, and we want to do some easy things to get rid of as much formatting as we can. So let's go back to our R Markdown. And the reason I saved this first chunk is because these options are going to allow us to do a few things, okay? There are global options that we can apply to each chunk. For example, in this little R box, we can take this echo option and we can make it false. This means that it will not print your code. It'll only print the results of the code, right? So if we're telling R, for example, to print names, and we see the names of our variables here, it'll print that in our document. So I need to delete that to get rid of that. Now, instead of going through and modifying each chunk, I can set the options globally. I'm going to set an option to false. I'm going to set, what else am I going to set? I'm going to set message equals false. And I'm going to set warning equals false. The next thing that I'm going to do is I'm going to set some other options. Should pop up here in base. Oops. Yep, options. And I'm going to set SciPen to 999. The reason I'm doing this is because if we look at our p-values, it gives us these really long p-values, or it'll print them in scientific notation. So that'll stop that. We can also set our digits to only print 3 digits. And for some of the output, when we're looking at it in the R Markdown window, it'll make it easier to navigate our output. So if we set these options and then we knit our document to Word, we'll have a little nicer document here with just the table that we want. So step 1, we've got a nice table. We did a regression analysis and we reported these results, and we don't have to do very much to make our Word document nice and useful. Alternatively, if you wanted to print your code and see the steps, you could change echo to true. So let's move on and let's do something else. Now that we get the basic idea of selecting the kinds of information that we want and then printing it out, we're going to print something into text. Now, in between each of these boxes, the chunks, we can type actual text. Text goes here. Text goes here. And then in between these chunks, the chunks are denoted by these tick marks, an R, and then 3 more tick marks. Now, these tick marks are actually ticks. They're not the single quotes. The single quotes on my keyboard are right next to my return key, whereas the tick mark is right next to my numbers key. It's a US keyboard, but the UK keyboards are different. So it's a tiny little tick mark. Now you need the ticks at the beginning and the end of the chunk. If you don't have a complete chunk, you'll get errors. So that's one thing to keep in mind. But this means that we can do some cool formatting things in Markdown if we use these hash mark headers, okay? This is a top level header. And this is a second level header. And we can even do third level headers here. And below these, you know, we can type regular text and we can report the results of our analyses in text, just like we can with the tables. So if we knit this, and I'm just going to knit at each step so we can see exactly what we're doing. We're going to get a document that looks like this. So notice text goes here in the chunk that I typed around disappeared, but we get different level headers, top level headers, second level headers, some regular text, third level headers are smaller. And we can report the results of our analyses in text. Now, the way this works, just to give you a quick example, let's make a value called num, and let's give it a value 5. So I'm just creating an object, num, and it's got a value of 5. The value of num is, and what we want to do is we use the tick mark R, and then we just type the object that we want to print. And you'll notice that it changes color to blue. Remember, it's the tick marks, not the quotes. And whenever we print that, it's going to print the value of num. Let's take a look and see what happens. The preview window is too small, so I'm just going to keep opening Word and showing you. The value of num is 5. Num is 5, and here I've just got the value of num is num. We tell the tick mark that tick marks mean this is code, this is R code, and this is the value that I want to print. And there's got to be a space there, otherwise it won't work correctly. So this means that anytime we have some sort of results, we can save that aspect of our result to an object, and then we just tell R in the text to print that object. So let's do a little t-test here. T.test, and let's look at happy by condition again. And we're going to get a t-test. Okay. Now we're going to have the same problem as before, where it's going to give us this text that's just sort of out there. It's not in a table. We can't really do anything with it. So one thing that we could do is we could find out how to save those results to a table, pipe it into flex table, just like we did before, and then we can print a table. But here I want to actually type these results in text. I want to say something like, you know, we conducted a t-test to compare happiness scores between conditions. Now, this is very useful because what I do when I pre-register my analysis plans is I come up with an analysis script. I will type out my results. I'll generate some fake data and go through the analysis process. And I'll type up my analysis results like this so that whenever I get my actual results, all I do is save it to the folder where my markdown is. I hit knit, and then I look at my results. But this also means that I kind of need to type out some things ahead of time and think about the best way to report them and describe them and plan ahead. And it's very useful, I find, to overcome some issues or things that I didn't consider with my research ahead of time. So I'll type out something like this. We conducted a t-test to compare happiness scores. The test was, I don't know, because I'm not going to have the real results yet, and I'll just change that in the text afterwards. You know, the text was significant or non-significant. And normally, the results are going to be reported something like this, where we're going to have a t with the degrees of freedom and a t-value, p-value, and then a d-value. So this means that in order to get each of those little pieces, okay, I need to find out how they're saved to this t-test output. Now, we can go and look at the values for the t-test, and we can see the values that it'll print out, or we can use this function called structure, str with the parentheses, and it'll tell you the names of each of the objects there. And these first level headers with the $sign are going to be your first level objects. And then sometimes they'll have multiple objects under there that you can select. In this case, statistic is our t-test, parameter is our degrees of freedom, p-value is the p-value, confidence interval is the confidence interval, okay? So on and so forth. The other thing that I'm going to use here is going to be, what is it, LSR, I think that's what it is. To get my Cohen's d value. So LSR, Cohen's d, let's do, I think this is right. Yep, so that's gonna give me a Cohen's d of 0.52, and that's nice because that's the only thing that it spits out, so we don't really have to select it or anything like that. We can save this to a value called d, okay? We can take, we need a t value. Okay, we need degrees of freedom. Let's call that degrees of freedom. We need a p value. And we need our d value. So we need to select these options from t-test. We need statistic, and all of these options here are going to pop up. We want statistic. We want degrees of freedom is called parameter. I mean, we could go and check and make sure 84, and we're going to have a bit of rounding here, right? 84.3, because I selected this rounding option up here. And then our p-value is called p-value. So t-test and p.value. Now, we're going to run this chunk, and that means that if we just print t, we're going to get a t. If we just print, p, we're going to get the p-value. So all we need to do is fill in the gaps down here in our text box, where the actual text is going to go, and we're going to use tick mark R, and we're going to type in degrees of freedom. We're going to do tick mark R for T. We're going to do tick mark R for P, and then tick mark R for D. So that's what it's going to look like. Be sure that you have the spaces in there. Sometimes it's easy to get cross-eyed and make a mistake. But let's knit this and see what this looks like. Great. It fills in our results for us. I hope that's not too small. So basically, when I get my real results, I'm going to look at it and say, oh man, okay, that was significant with kind of a large effect size, and I'm just going to change that to significant. And it's got our degrees of freedom, our t-value, our p-value, our d effect size, everything. Now, we need to get rid of this stuff here. Why is it doing that? I have echo false, echo false. Well, I'll come back to that in a moment. So that's basically what you can do to report any sort of result in text that you want to. This means that if you want to compute average values, okay, we have in our fake data set here a couple emotions that we might average into a composite score. And we could do, like, if we wanted to do Cronbach's alpha, we could print using the LTM package Cronbach's alpha. We could select some variables using dplyr. We can select happy and sad. And then we can do the alpha variable, alpha analysis on that, which is going to give us our alpha score. We could look at the structure of that, and we can find that the value is called alpha. We can save just that value to an object, and we can say, we combined the happiness and sadness scores into a composite. And then we can type in the alpha value equals alpha, just like that. So you can select the content of any statistical output that you want, print it into text, print it into tables, however you want to report things. You can play around with it and do some really cool things. I'm going to show you really quickly. I want to save enough time for questions, but I want to show you a couple other options that we have here for making some really nice tables. And one thing that, especially when I was in grad school, I used to have a lot of dreams about getting my correlation tables to line up. You have to fix decimals and change rows and columns and things. And if you're copying results from, like, say, SPSS output, it can be really difficult to get these things lined up and looking really nicely. So we're gonna, let's make a correlation table. And I'm just gonna copy and paste this in to save some time. This is gonna use the CoreX library. So install the package CoreX. And all I'm going to do is I'm just going to select a couple variables from my data frame, 3 or 4 variables here, happy, sadness, choice, and I'm going to save them to an object called CoreDF. Now, this CoreX function has lots of little arguments that you can add in here, okay? It's going to, let's take a look and see what this looks like. Whoops. It's going to spit out a correlation table for you like this that's formatted. It can include means and standard deviations. And again, all of this stuff is going to be in the Markdown file that we'll share on the OSF page, so you can copy and paste and reuse this code all you want. You can add in means and standard deviations or whatever other summary statistics you want. It's going to give you the asterisks for significant values. You can do Pearson's correlation, or you can do Spearman correlations. This triangle just gives you half of the triangle for the values. Otherwise, it would give you values on top and bottom. And we're going to do the same thing as before, right? Core X is going to print out a table like this. And all we need to do is pipe it into a data frame. I'm going to add that row names to columns argument again, and then pipe that into flex table. And that gives us a nice correlation table just like this. Oh, where did my alpha value go? It's because I didn't save it to alpha. So the last step in my workflow is basically I'm just going to have R print out the results of my analyses, the results of my tables like this. And then I'm just going to do a little bit of formatting in Word, make them nice and centered or whatever it is. And because I will have written my introduction or my method section in Word, basically I could just take my results section and paste it into my final Word document. And that's kind of what my workflow looks like. There are other ways to do things, a little more complicated steps to make things look nicer. And there are some resources online and resources that I'll share to help you with that. I'm going to stop sharing my screen now. To help you with that. And as I mentioned, there's some other options on here to print graphs. There's some other options here to get, for example, simple slopes and interaction analyses. That you can do in 1 or 2 lines of code that will make your reporting a lot simpler. So I guess we'll stop here for now, and I'm happy to take any questions about the process or even redo some steps if I went through something a little too fast.